Good afternoon, everyone. I am Dr. HimaBindhu from the Department of Mechanical Engineering, and I will be dealing with the robotics subject. And my today's topic is feedback components. What do we mean by feedback components? Yes. What is a feedback component? It is one of the important and crucial component which is being used in robotics. What do we mean by that? Actually, that is, this particular feedback component is nothing but it is the device which is used to give us the response to the robot. That is, it is a precision control device of the robotic system. Right? The feedback component system is one of the crucial and very precise control of the robotic system. So this particular feedback component, depending upon the type of the sensors, is being differentiated in various component systems. Right? So these components generally are used to give information to the robot from its surrounding, or depending upon the type of the action being recorded by the robot. In order to give the information to the robot, these type of the sensors are very helpful. So there are some of the key feedback components which are commonly used in our robotics, such as position sensor and encoders. Right? Such as position sensor and encoders. Where this particular position sensor, what do we mean by the word position sensor? Right? Firstly, the sensor is divided into two types. One is the external sensor and one is the internal sensor. Right? The sensor is being divided into two types. One is the external sensor and one is the internal sensor. So generally in the external sensor, we find out position, the position sensor, the velocity sensor, the acceleration sensor, or the force or moment sensor come under the external sensors. Whereas in the internal sensor, come across temperature sensor or visual or proximity sensor. Right? So firstly, the sensor is being divided into two categories. One is the external sensor and one is the internal sensor. So external sensor means what? What generally is known by the external sensor. As a human being, we also have some sensing devices. Right? As a human being, we also carry some sensing device where eyes, nose, ears, mouth, skin, tongue, all these come under few of the sensing devices, right, with the help of which we can sense what is going on around our surroundings. Right? With the help of our eyes, we can visualize what is going on in the surrounding. With the help of the nose, we can hear, though the eyes are closed and though the ears are open, we can identify what is going on around the surrounding. And with the help of the touch sensor, though the eyes are closed, by touching any particular object, whether it is square, spherical, circle or rectangle, we can identify it with the help of the touch of that particular object being placed. So these are some of the sources which are acting as the internal sensors. Right? So the examples of the internal sensor are temperature sensor, visual sensor and proximity sensor. What happens in temperature sensor? Same like our human body, as there are some amount of the rays being reflected onto our skin. And how the way we react the same way, the robot also has a temperature sensor being placed to its end effector, right? To the end effector, that is to the robot gripper, these particular type of the sensors are being placed, right? Sorry, these are the internal and these are the external and these are the internal, right? So based upon these particular visual, that is eye, with the help of the eyes we can see the work, whatever is been going on in its surroundings. So these are called as the external sensors, and the position sensor, the velocity sensor, the acceleration, force or momentum sensor comes under the internal. That is same like our body. If there is any pain, muscular pain within the body, we will be identifying with the help of the pain and we apply some particular ointment depending upon the requirement. So in the same way here, the robot also, when we need to identify, when we need to move from one place to the other, we require some position sensor, right? In order to find out the acceleration, or in order to find out the force and momentum of that particular robot, we need to have these particular type of the sensors which come under the internal sensor. So here the position sensor is again been divided into two categories, that is potentiometer and resolver, right? So again the position sensor is been categorized into two types, that is potentiometer and resolver. So depending upon the requirement, this particular position sensor will be acting. Whereas the next type of the sensor is the encoder, right? Again this encoder is divided into two categories, that is velocity sensor, tactile and rate sensor, and force and torque sensor, which come under the internal sensor operation. So these are all the examples of internal sensors, right? So here generally the position sensor is in the robot provide the essential requirement, the essential data about the position and orientation of the robot, right? The position sensor is used to give the essential data, that is in order to know the position and orientation of the robot, we can find out that with the help of the position sensor, where it is divided into where it has been divided into potentiometer and resolver. So before we proceed into this potentiometer, depth into the potentiometer, let us see again this sensor is again being divided into two categories, that is contact sensor and the next is non-contact sensor. Right? Again, the sensor can be varied depending upon the contact and non-contact sensor. So what generally we mean by contact sensor? Contact is again being divided into two types, that is touch sensor or binary sensor, and the other one is force sensor or analog sensor. The contact like sensor is nothing but like visual sensor or range sensor, right? So again this particular sensors are being divided into two types, that is contact sensor and non-contact sensor. By the name itself we can identify. Contact sensor means what? When a robot is having any contact with any particular object, so that particular type of the sensor is known as the contact sensor. And the robot which can just be visualized, which can just gather the information without contacting the particular object, we call that particular type of the sensor as non-contact sensor. So generally the examples of non-contact sensor are visualizing sensing or range sensing. For example, we need to draw a line of some 10 mm. right? For example, we need to draw a line of 10 mm. We are drawing a line of 10 mm, right? And again, in the next step, they asked us to draw a line of 20 mm, right? They're asking us to draw a line of 20 mm. So initially, we have drawn the 10 mm, and by the range proximity, by the range sensor, as we have the visual sense and we have the range sense, by extending this line to another 10 mm, we can draw a 20 mm line, right? We can draw a 20 mm line. Initially, we are drawing a 10 mm line with the exact dimension, and after that, by visualizing and range sensor with our intelligence, we are drawing a 20 mm line by seeing the 10 mm line. So that comes under the non-contact sensor, that is visual sensor or range sensor, right? Whereas in the contact sensor, we come across two types. One is the touch sensor and one is the force sensor. Touch sensor means what? What do we mean by touch sensor? Yes, what do we mean by the word touch sensor? What happens here in the touch sensor? That is, when the object is touching any particular component, then it will sense and gives us the feedback component. That is, when the object is touching. For example, we have the end effector. For example, let us take an robot finger, that is, which is attached to a robot arm, and in between these particular two robot finger, we are placing a object, right? We are placing an object. So when this particular object is being touched, right, so it is sending signal to the robot intelligence. So it is sending signal to the robot intelligence that so and so object has been pulled and we are moving it from one place to the other place. So this is known as the touch sensor. So that is, here we are placing the touch sensors to the fingers of the robot, where this particular end effector is being connected to the robot arm. And in the same way, force sensor. Force sensor is, that is, how much amount of the force we are applying on that particular object, right? How much is the amount of force we are applying on that particular object will be determined by the force sensor. So that cannot be generally known by a visualizing effect or by some range sensing device. That can only be identified with the help of the touch being done to that particular object. So this comes under the contact type of the sensor, that is nothing but the touch sensor, or it is nothing but the type of the force sensor. Now next, moving on to the potentiometer, that is, potentiometer is nothing but one of the type of the position sensor. So what exactly happens in position sensor? Position sensor is generally used to identify the position and orientation of the robot or any of its part. So here the potentiometer is used to find out the linear displacement or the angular displacement theta, right? The potentiometer is used to find out the linear displacement or the angular displacement, that is nothing but theta. That is, with the help of the potentiometer, we will be finding out linear and angular displacement in terms of voltage, right? In terms of voltage, we will be finding out this particular displacements of the robot. So here in this type of the potentiometer is one of the commonly used position sensor device, right? The potentiometer is one of the commonly used position sensing device. So here this is the figure of the potentiometer. Right? This is the figure of the potentiometer, where this will be fixed to the robot in order to identify its linear and angular displacement. So, it is nothing but the combination of potential difference and the metering. The potentiometer is nothing but the combination of the potential difference and metering. So this particular potentiometer is an instrument which is used to measure the unknown voltage. Right, as I've told you, it is the instrument which is used to find out the unknown voltage, that is V out. Right, we will be finding the unknown voltage V out with the help of the displacements and with the help of the input voltage being given to that particular potentiometer. So this determines the EMF and the internal resistance of the particular cell. The potentiometer is used to determine the internal resistance and the EMF of the particular cell or any particular different cells. So commonly the potentiometer is used to control the electrical devices. Like generally it is used to control the electrical devices, and it is also called as position transducer. Right, the potentiometer, since it is controlling the electrical devices such as volume control, audio control, it is also called as position transducer. Right, so let us see the working principle of the potentiometer. Generally, we will be having an input voltage. Right, we will be having an input voltage. Right. So this is how generally the potentiometer is being circuit is being designed, and here this is the V in through which the current is being generated with the help of the battery, and as the current from the battery is circulated within the circuit, this particular wiper, that is the voltage out is being generated. So when the voltage out is being generated, this particular wiper starts moving. Right, this particular wiper starts moving, and in order to find out the displacement with the help of the potentiometer principle will be determined as V in by capital R. That is not, this is the reference with the help of which we calculate the linear displacement and angular displacement. So in order to find out the linear displacement, the formula is V in by R, which is equal to V out by small r, where capital R is nothing but the resistance of the overall potentiometer, and small r is nothing but the resistance of the with respect to the wiper. Right, where small r is nothing but the resistance with respect to the wiper. Right, and with the help of this input voltage and with respect to the output voltage and the resistance of the potentiometer and resistance of the wiper, we will be finding out the angular displacement, and accordingly with when V out or R is known, we can even find out the angular displacement, that is theta. Right, when V out that is output voltage, and when R is being known, we can even find out the angular displacement. So this is how the potentiometer will be working. That is the basic principle of the potentiometer, is that the potential drop across any of the section of the wire will be directly proportional to the length of the wire. That is, V is directly proportional to the length of the wire, that is it is proportional to 1, or we tell it as V is equal to K into 1, or K is equal to V by L, where K is nothing but the constant, potential gradient constant. That is the principle of the potentiometer directly depends upon the potential drop across any section of the wire, which will be directly proportional to the length of the wire, providing the wire is of the uniform cross section. Right, when it is in the uniform cross section only we can find out this. So this is how the potentiometer will be working. That is, as the amount of the energy is being generated through the battery to be in, it is being passed to the particular coils of the potentiometer, and the output voltage is being generated with the help of which the wiper starts moving, and the displacement and the angular displacement will be calculated accordingly. Right. So this is the construction. That is the same thing which I have shown you now. So as long as the resistance wire or the length vary from 1 meter to 10 meter stretch, the point A and through the point A and B, it is generally at 1 meter to 10 meter stretch from point A and B, and meter scale is being fitted to the wooden plank. Here we have a meter scale, right, which is being fitted to the wooden plank. So the steady current is maintained in the wire by a connection across A and B. By the connection across A and B, we have a standard current being passing, and this particular thing is being working, right? This particular potentiometer will be working. So generally, the potentiometer is generally used to control the volume, as we have seen earlier, in order to control the brightness control, in order to have a sense and control in the robot, in order to turn control in the turning control in the radius or voltage dividers. We generally use this particular type of the potentiometer. But one of the disadvantage of the potentiometer is that it is temperature sensitivity. Right, one of the demerit of the potentiometer is it is temperature sensitive. Right, whereas we have few advantages, like they can be used in the application with large travel requirement, and it can be used for limited amount of feedback control, right, and it is also used as for with high proportion, resolution and accuracy are not any particular requirement. So these are few of the advantages of the potentiometer, whereas one of the disadvantages is that it is temperature sensitive. Right. So generally, the potentiometer are analog. These are also called as the analog devices, where these particular devices give output voltage which is proportional to the position of the wiper, as we have discussed in the earlier figure. Right. That is the output voltage. With the help of the output voltage only, we get the position of the wiper, with the help of which we will be calculating the linear displacement and the angular displacement. And this particular potentiometer offers low cost method. That is, it is one of the low cost method which can be used in robotics. So depending upon the design, there may be variation. That is, there may be either rotary type or linear type of the motion. Depending upon the type of the design of the robot, we can take this particular potentiometer either in rotary type or linear type of the motion. In the other cases, this particular potentiometer is also called as a movable slide or a wiper, which is in contact with the resistive material or wire winding thing. And the amount of the power, whatever has been generated, will be either direct current or alternating current voltage in applied to the resistive material. So this is all about the potentiometer. That is, the potentiometer is nothing but it is used to determine the linear displacement as well as the angular displacement, right, of the particular wiper, with the help of which the position and orientation of the robot can be identified. Clear? So in the next class, we will be discussing about the resolver and what are the types of resolvers, how is the working principle of the resolver, all that we will be seeing in the next class. Hope you have understood the class. Signing off for today, Dr. G. HimaBindhu.
Like, share and subscribe. Hit the bell icon for more updates.